studying. So today we'll be going to discuss the hybridization concept, the valence bond theory, molecular orbital theory, and hybridization. They are the three concepts that we're going to study in this chapter, that how the chemical bond is formed. Okay, understood? So let's start studying. The today's topic is hybridization. Hybridization. Where does the concept come from this? And how does hybridization, what does the word hybridization means actually? When we come to the, and we discuss about the structures of CH4 according to the valence bond theory. So what we study here is that in carbon, if the electronic configuration of carbon is 1s1, 1s1, 1s2, 2s2, 2p2, okay, 2p2. And in the excited state, the carbon, this is the ground state electronic configuration. Okay, this is the ground state electronic configuration. And if it goes into the excited state, then it is going to have this type of electronic configuration, means this electron will jump into this one. Okay, now here the hydrogen is going to make bond. The hydrogen, the electronic configuration of hydrogen atoms. So if we make the carbon atoms, the first shell is actually this shell of carbon atom is 1s, and this is sorry 2s. This shell is 2s having one electron. Okay, this shell is of p orbital. This shell is of p orbital, or we can say that it is 2p. This is 2s shell. This is 2p shell. Another one is actually, this is 2p, this is 2px, this is 2py, and this is, the fourth one is 2pz. Okay, and all of them are going to have one electrons. So when the bond formed between 1s and 1s of hydrogen should be different from the bond formed between this hydrogen atom, this hydrogen atom, and this hydrogen atoms. Actually, the bond formed between 1s and 1p, this should be more stronger bond between, because they have more overlapping, or we can consider that this bond should be more stronger. And then 1s of hydrogen, 1s of hydrogen. So when 1s of hydrogen is going to mix with 2p of p orbital of carbon, then the bond must be more stronger as comparison to 1s and 2s. Okay, so but actually when we observe the structures of this carbon, so we find that all the bond, or this methane, we find that all the bonds are of same bond length, and have equal bond length, and have equal bond angle, and they have equal power. Okay, means no one is going to have, we cannot say that this bond is weaker, this bond is stronger. So there is a hypothetical, we can say that there is a concept comes to explain this one. This is the hybridization. What does according to this theory, what does this means? They say that when we have 1s orbital of carbon of central atom, and 2px and 2py and 2pz, 2px, 2py and 2pz. Okay, and this is, okay, this is 2s orbitals. Okay, this is going to have one electron, and these are going to have one electrons. Okay, then what is going to happen? They will intermix each other, means they will mix up each other and make a hybrid orbitals. We named it S1 and PR3, so we will name it sp3. And there will be 4 hybrid orbitals that will be made from this one, and their name will be sp3, 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 sp3. Okay, they are the hybrid orbital. For example, s orbital is like this and p orbital is like this, then the shape of sp3 orbital will be like this. Okay, the shape of sp orbital will be like this. Okay, so this is p and this is spherical shape, so they will intermix each other, means this s, 1s and 3p will mix each other. So if we have hybrid orbital, 4 hybrid orbital which is of sp3 shape, so it will be like this. First, second sp3, third sp3, and the fourth sp3. Okay, and this is like this. And here the hydrogen atoms will combine, here the hydrogen atoms will combine, here the will combine here. So this is that for equal, we can say that this is a concept of hybridization, that whenever a molecule is going to make or is going to form, and they are different orbitals, one s and p and d. So if what is going to make, if they are going to make bonds of equal energy, of equal bond length, then they mix together, means s orbital of carbon and 3 p orbitals of carbon will intermix each other and make new hybrid orbital. Understood? Understood? What does the word hybridization means? Understood? Everybody in the class?
Yes.
Yes, sir.
Okay, so let's move.
Sir, you're muted.
Is I'm audible to you? I have been continuously speaking for 5 to 10 minutes. My mic was mute.
It got mute just as you started writing the definition.
Okay. That's why I was just asking. Okay, please note it down. Okay. So here, okay. So what does this theory is about? If I ask about that, what does this theory mean? This theory is based on intermixing of atomic orbitals. Okay. So it is based on intermixing of atomic orbitals. Okay. The main points of hybridization What are the main points of hybridization? First, that the atomic orbitals of center atom will undergo mixing. Means the only the atomic orbitals of center atom is going to intermix, not of the other element that is combining with the central atom is going to mix. No, only the atomic orbital of center atom is going to intermix. Okay, understood? Understood? So what does it say? The atomic orbital of central atom, atomic orbital of central atom, okay, will undergo mixing process. Okay. And the next one is the number of hybrid orbital, means new hybrid orbital that are going to form by intermixings will be same as that of the atomic orbital that was mixing. For example, we have 1s and 3p, 1s in carbon, and px, 2px, 2py, and 2pz, three orbitals of this one. If they are going to mix, then they will be going to form new 4 orbitals. Okay, so if we are mixing the 4 atomic orbital, then the new molecular orbital that will be going to come, that will be a new hybrid orbital that going to form will be same as that of number of atomic orbitals. Okay, so we will say that hybrid orbitals is equal to the number of the hybrid orbital is equal to the number of atomic orbitals. Okay. Okay. And the half filled and the fully means half filled, fully filled, and vacant orbital of valence shells. Okay. If I'm talking about that, which type of element? Only the half filled, fully filled, and the vacant or of the valence shells are going to intermix. Those they are already paired, they are not going to mix. Only the half filled or the vacant orbitals, half filled, fully filled, and vacant orbital of valence shell of center atom undergo mixing. Okay. So have you noted this one? Should I move further?
Yes.
Note it down that half filled, fully filled, okay, and vacant orbitals of valence shell of central atom will undergo mixing process. Okay. Understood?
Yes, sir.
Noted this one. So if we have 1s and 3p orbital, they are going to mix. Then how many hybrid orbital will be formed? New hybrid orbital will be formed. Tell me. If we have 1s orbital and 3p orbitals, they are going to intermix. Then how many types of new hybrid orbital will be formed? Tell me. 4. How many? 4. Because if you have 1s and 3p, so 1s and 3p, 1 plus 3, 4. Okay, so the number of atomic orbital that will be intermixing, will be equal to the number of hybrid orbital formed. Okay. Okay, understood this point? No, huh? Understood?
Yes, sir.
Now moving to the next point is all hybrid orbitals okay, all hybrid orbitals are similar in structures and energy, but may differ from each other in orientation. Okay, orientation in space. Okay, like arrangement. We are talking about arrangement. So if I'm talking about that, if you are having 1s and 3p orbital, they are mixing together. So they will form new 3 sp3 4 hybrid orbital. Okay, new, and they will be having different axis of orientations. Okay, they may be in different planes. For example, one hybrid orbital can be in this plane, another can be in this plane. Okay, so their arrangement can be different. Okay, third one can be in this plane, fourth one can be in this plane. So there can be different planes of them. Okay, and understood?
Yes.
Okay, so moving to the next point here is if we are having example, for example, taking the example of benzene. If we are having benzene, okay, so in benzene each carbon atoms Okay, so if you talk about that, if you take out this means hybridization of this one, so there will be sp2 hybridized orbital, sp2. There will be sp2, this will be sp2, this will be sp2. Okay, sp2. So there will be all sp2 hybridized orbital. Okay, and how we calculate the hybridization, we're going to discuss this one, that why carbon is going to have sp2, why the carbon of methane is going to have sp3 hybrid orbital. So we're going to discuss this one. Okay, unhybrid orbital, that we can say that next point, the unhybrid orbital, if the orbit is not, or the orbital that is not hybrid, it make pi bonds. Okay, so this is very important, that if the orbital is not hybrid, not considering in the hybridization, then it make pi bonds. Only the hybrid orbitals make sigma bonds. Okay, so the orbital that are making sigma bonds will be hybrid orbitals. So let's discuss this one, and let's unite this one, that unhybrid orbitals form pi bonds. Okay, we can say that the process of mixing of atomic orbitals nearly same energy, okay, and produced a set of hybrid orbitals is called hybridization. Hybridization. Understood? Note it down. The process of mixing of atomic orbitals of nearly same energy. Only same energy atomic orbitals are going to intermix. If there is a difference in very much difference in the energy of the atomic orbital, they don't mix each other. Okay, understood? Unhybrid orbitals make pi bonds. Done?
Yes, sir.
So if we're talking about the benzene structure, okay, here the carbon is going to have 1s and 3p. Okay, 3p orbitals. So if we know that here 1 carbon and 1 sigma, and here 3 sigma bonds are made. So 3 sigma means 3 single bonds are made, and 1 is pi. So only if 3 sigma bonds are made, so only 1s and 2p orbital will go for the mixing, and will form new sp2 3 hybrid orbital. Okay, you know the structure of benzene. 1 carbon atom is bonded with 2 other carbon atoms with 1 single and 1 double bond. Okay, and 1 is with hydrogen. So each carbon is making here 1, 2, 3, 3 single bonds. So we have, if carbon need to make 4 single bond, then it will intermix all 1s and 3p, and will result sp3 hybridization. Will result in sp3 hybridization. But if it is need to make only 3 sigma bonds and 1 pi bonds, so since unhybrid orbital which is not in the hybridization will make pi bond. Okay, so 1, 2, 3 will make sigma bond. So then since carbon is going to make here only 3 sigma bonds, 1, 2, 3, each carbon atom is making 3 sigma bonds. So only for 3 sigma bond, 3 hybrid orbital is being required. For this, only 1s and px and py orbital is going to intermix, and they will form sp2 hybrid orbital. This pz will not make, because this is going to make pi bond. Okay, double bond. Understood? Understood?
Yes, sir.
Should I move forward?
Yes.
Now, how will we determine determination of hybridization? How can we determine the hybridizations? Okay, so for molecules For polyatomic ions or cations. We are generally talking about cations. Cations, and for polyatomic anion. Anion is negatively charged. Okay, negatively charged. This is cation is positively charged, and this is neutral. So for this one, we have simple number of means hybridization. We need to calculate the number of hybridization. Okay, so this is valence shell electron plus number of monovalent atom. Okay, attached to valence, number of valence electron. First is V, number of valence electrons in the central atom, and the second one is that is number of monovalent atom that is making bond with this one and divided by 2. Okay, if we have any positive and negative charge, then we have valence shell plus number of monovalent atom and minus the charge on the cation. Always the charge is, because electron is being, when we have positive charge means electron has been donated, so the charge acquired by the ion is just means since the electron is not here, so we minus the charge. If an electron lose 2 charge, it has 2 positive charge. If an electron atom lose 2 electron, then it has 2 positive charge. If it lose 3 electron, then it has 3 positive charge. Okay, so we always minus the charge of cation divided by 2. And the third one is for anion, we have V plus M plus A upon 2. Okay, anion's charge is always means if there is negatively charged, means if we had to go an extra electron, so we have another. Okay, understood? This one. So please note it down that H is the hybridization number. Yeah, hybridization factor. Hybridization factor. The second one is V is number of valence electrons of central atom. Okay, in free state. And the number third is M is number of monovalent atom or group attached to central atom. Please note it down. Monovalent atom, you understood what is monovalent atom? Like fluorine, chlorine, bromine, iodine, hydrogen. That is valency one. Okay, and group attached means, what does the word group attached means? Group attached means if monovalent group, that means that has valency 1, like OH, like CS3 minus. Okay, so if this is a group is attached, then we will discuss it. Okay, please note it down. Done.
Yes, sir.
You also, Alvina? Sorry, Lavina?
Yes.
Sorry, Lavina, no, Lina. Done, everybody? Okay. So let's move further. Okay. Now if we have the value, means if we got the value, if we got the hydrogen hybridization factor, factor S2, then the type of hybridization of hybridization, types of hybridization will be SP. Okay. If we have 3 hybridization, then it will be SP2. If we have 4 number, then we have SP3. If we have 5 as this number, then we have SP3D. Okay. If we have 6 this number, then we have SP3D2. And if we have 7 this number, then we have SP3D3 hybridization. Okay. Got it? Done? Please note it down. And tell me that what is the hybridization of SO3? Hybridization of sulfur in SO3. बताइए. Tell me what is the hybridization of sulfur in SO3? How many valence electrons are there in the outermost shell of sulfur? 6. Is there any monovalent atom? No, oxygen is divalent. Okay. There is no monovalent atom. So we will write 0 divided by 2, you will get 6 divided by 2, you will get 3. If the number is 3, then we have sp2 hybridized. Then the types of hybridization is sp2 or sp3. Understood?
Yes, sir.
So here sulfur is sp2 hybridized. Next, find out the hybridization of XeO3F2, and you find out the hybridization of xenon in XeO3F2. Find out. Tell me. Why are you not answering? Can you please turn on your camera with it and let me check whether you are writing properly or not? Is it possible to turn on?
The hybridization of
Yes.
is sp3d.
sp3d, very good. And Lena, you understood? How sp3d?
Yes.
Tell me how. Tell me how it is sp3d. Xenon is a noble gas. Xenon is a noble gas. And except helium, all noble gas have 8 electrons in their outermost shell. So xenon is going to have 8 valence electron. Okay. So if we need to take out the hybridization number, so here we have 8 valence electron of xenon, and the monovalent atom means that has only valency 1, and that is fluorine. That has 2. F2 means 2 fluorine atoms are monovalent. There is no charge, so we will not write it. We will divide it by 2. We'll get 10 divided by 2. You will get 5. And when you have a number 5, then you have sp3d2. Sorry, sp3d. sp3d only. Okay. Types of hybridization will be sp. You will get 5, 1, 3, 4, and 1, 5. Okay. Understood?
Yes, sir.
Calculate the hybridization of XeF5 positive. Calculate it.
The hybridization is sp3d2.
sp3d2. Again, 8 plus 5. And this is plus charge. So the plus charge is always minus. So you'll minus plus charge upon divided by 2. So you'll get 8, 5, 13 minus 2. You'll get 12. Minus 1. You'll get 12 divided by 2. You'll get 6. And for 6, we have sp3d2. Very good. Very good. Okay. Calculate the hybridization of SF minus 6. Last SF6 minus 1. Calculate the hybridization of this one. Calculate it. I will be coming back. Done? Lena? Done? What is the hybridization of SF6 minus 1? Lena, are you there?
Yes.
So tell me the hybridization of SF6 minus 1.
sp3d2.
sp3d2. Okay, let's check. Sulfur is going to have 6. And we have 6 monovalent atoms and 6. Okay. And then monovalent atom, if we have, sorry, this is 2 here. Sorry. This is minus charge will be minus 2. Okay, that is not it. So we add the minus charge. So they are the 2 minus charge. Okay, then divided by 2. You will get 2 and 2. You will get 14 divided by 2. You will get 7. This will be sp3 and d3. Okay. Understood? This was mistake here that I wrote here minus 1. It should be minus 2. Okay. Should I move forward?
Yes.
Okay. Now the next topic is types of hybridization. Types of hybridization. Okay. The first one is sp hybridization. 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 Okay. So if I talk about sp hybridization, we have, for example, first one s orbital, yeah, any s orbital. S orbital is spherical in shape and p orbital is dumbbell in shape. Dumbbell. Dumbbell. Okay. So this is p orbital. This is p orbital. Okay. So when it mixed together, it will gives you how many sp orbital? Tell me how many. So they will intermix either. They will undergo intermixing. Okay. And when they undergo mixing, then they will be going to form sp2 sp hybrid orbital. Okay. Like this. This is sp hybrid orbital because they are the two orbital A1s and 1p. So there the new hybrid orbital form will be also 2. Okay, this is also sp. And how they will arrangement? How will they will arrange themselves? They will arrange themselves like this way. Okay, so this is sp and this is also sp. Understood? Understood? Understood?
Yes.
So if we have one s and one p, so they will be arranged. So if a molecule is going to make bond with this p, with this hybrid orbital, okay, like this s orbital is going to make bond with this sp. So since its shape has linear, means it is like this, right shape, so they will arrange themselves and the shape will be linear shape. Okay, the geometry will be the, so we can say that if the central atom has sp hybrid orbital, then the shape of the molecule will be linear. Okay, so we'll call geometry of molecule will be linear. Okay, and bond angle will be of 180 degree. We'll note it down. Linear matlab straight line. Okay. For example, formation of BeF2 molecule. BeF2. Done. This one. We're talking about BeF2. Beryllium difluoride. So beryllium, if I talk about the electronic configuration of beryllium, is 1s2, 2s1, and it is 1s2, 2s2 only. But since it need to make bond with 2, okay, then it goes in the excited state, and this is going to have 4 atomic number, beryllium, but it's in excited state, it is going to have 1s2. This is the inner orbital, so don't discuss this one. Only take 2s1 and 2p1. Okay, so when 1s and 1p orbital intermix together, they will make 2 new hybrid orbital, that is of sp hybrid orbital, and they will be in the shape of this one. Now, if fluorine is going to have electronic configuration 2s2 and 2p5. Okay, 7 electron in the outermost shell, 2,7. So it will be going to have only one p orbital as unpaired. So that p orbital will make bond like this. That p orbital will make bond like this. That will be of original shape, and that will be of original. Okay, so this will be the structure of BeF2. Okay, this is fluorine orbital, p orbital. This is also fluorine p orbital, and this is the central atom Be, which is going to have intermix orbital, which is sp. So two intermix, or the 1s and 1p of beryllium will intermix together and will form new 2 hybrid orbital, that is of sp hybridization, and their shape will be, what will the shape of this one will be? Tell me. Tell me. It will be a linear shape. Okay. Understood?
Yes, sir.
So here the bonding will be sp hybrid orbital with p orbital of fluorine. Okay, the sp is beryllium and p orbital is fluorine. Okay, and next, if we have sp2 geometry, Have you drawn this one? This is very important. Please note. Have you drawn this one?
Yes.
Okay. So if I move to the next portion here is, if we have another molecule that is talking about the new hybridization, that is sp2 hybridization. So if I talk about the new hybridization here, so you need to keep in mind, if we have one s and two p orbitals, one p orbital, another p orbital, they are going to intermix together. So how many new orbital will be formed? And they are not same symmetry, so they will be like this: one in the x and one other in the p. Y. This is px. Let it is py. So they are intermixing together, and how many new orbital will be formed? Tell me. Tell me. How many new hybrid orbital will be formed? Now the sp2 hybridal, and there will be three new 3sp, because there are 1, 2, and 3. 3 orbital are missing, so new sp3 orbital will be formed. These are all sp orbital. sp2, sorry. This is sp2. All are sp2. This is sp2, sp2, and this is also sp2. And how will they arrange? To talk about the arrangements. So they will be of same energy and same bond angle. So they will be at in a trigonal planar structure, means in a triangle like a structure like this. First will be in this direction. The second will be in this direction. And the third will be in this direction. Okay. Understood? So their geometry will be trigonal planar, means all the, if an element is making bond with this one, with this one, with this one, so the molecule shape will be trigonal planar, means all the three molecule will comes in the same shape. Okay. Understood? In a triangular shape. Okay. Understood? So geometry will be trigonal planar, and the shape of the molecule will be trigonal planar shape. And we can simply say here that the bond angle will be 120 degree. Bond angle will be 120 degree. Why 120 degree? Because there is one bond here, one bond here. So if three bonds are of same bond length and they need to set at maximum repulsion, so the maximum angle will be between them will be 120 degree each. Okay. Understood? If we have one at 90 and another this one, so it is not possible. Why? Because this will be at 2, because they are same energy, so they must have same repulsion. They will repel each other with same energy. So this bond, and this bond will repel each other. Okay. Understood? Understood? That
Yes.
so what is the shape of the molecule, which of the molecule if the central atom has hybridization? sp2 hybridized orbital. If we have sp2 hybrid orbital, sp2 means there will be 3 things, and 3 will be in the same maximum repulsion, so they will be having a shape of trigonal planar. Okay. And trigonal planar means that all the 3 angles, 3 bond will comes on a single plane. You can draw this one in the paper. They will not any single bond will comes out of the screen or into the screen. They will all lie on this screen. Okay. So they will be in the single plane. They can be drawn on the paper. Okay. Understood? Now, can you guess that what should be the shape of sp3 hybrid orbital? sp3. What is the shape of sp3 hybrid orbital? Tell me. The example of previous one is B boron tetrachloride. Or we have AlCl3 we can have. Okay. So mainly is boron tetrachloride. The example is BCl3. 3 chlorine atom will make bond with this one, with this boron, which is going to have 3 hybrid orbital of sp3. Okay, sp2, sorry. Should I move forward?
Yes, sir.
Yes.
Now tell me, if we have sp3 hybrid orbital, then what would be the shape? Can you guess me the shape of the molecule? Now we have four things. Like for example, if an atom is going to make four bonds, they can have this shape like this. sp3 means 1s and 3p orbital. px, py, and pz orbital will mix together and they will form new sp3 4 hybrid orbital. Okay, but you see here, if these are at 90-degree repulsion and these are at 180-degree repulsion, so this is not possible. This is not acceptable. So how can we, how, because why? Because they are in sp, or we can say if there is a hybrid orbital, then their energy, the energy of every orbital must be same, their bond angle will be same. If their bond angle is different, so it means that it is some mistake, or we can say that there is some, okay, means their bond energy should be same. If their bond energy is same, all hybrid orbital will make 1s, and if we have 3p, px, py, px, py, and pz orbitals, if they are going to intermix together, okay, then they will gives you new 4sp hybridized orbital, sp3. This is 4sp3 hybridized orbital, and then they will arrange themselves. They will arrange themselves in equal bond angles, or with an arrangement which is going to have equal bond angles. So this is, they will arrange themselves in a tetrahedral structure. So what is tetrahedral structure? Let me show you that. If you have a tripod like structure, like one is this, another one is this, okay, so this is tripod like structure. This, if we consider this one and this one in a plane, so this will be out of the plane, and this will be into the plane, means this will be coming out of the screen, and this will be coming into the screen. So this is tripod like structures. Okay, tetrahedral structure will be like this. Okay. Okay, so this is the tetrahedral structure. Understood? Understood?
Yes. Yes, sir.
This is the tetrahedral structure. So if we talk about this one, this is a tetrahedral structure. Okay. So 1s and s and 3p orbitals, and mixed together, they will give you 1s and 3p, means 1 plus 3 will gives you 4. So 4 hybrid orbital will be there. And this is when carbon is going to make all single bonds, then this, its hybridization is just like tetrahedral structure shape, and like example of methane. Okay, so there will be 4 hybrid orbital will be there, and they're going to have same bond angle. Okay, the structure will be tetrahedral. The shape of sp3 hybrid orbital, if an element, if in a compound central atom is going to have sp3 hybrid orbital, then the shape of that one will be tetrahedral shape. Okay, tetrahedral shape will be there if a central atom is going to have sp3 hybridization, and the bond angle will be same, that is 109.109 degree, 109 degree dot and 28 minutes. And what is minutes? The 60 minutes is equals to 1 degree. Okay, sometime it is also equals to, we can write it, because 28 means and it is nearer to 30 minutes. 30 minutes means half degree, so it is maybe written in some books like 109.5 degree. Okay, understood? So all bond angle will be of 109 degree and 28 minutes, which is exact, but here approximately it is taken as 109 degree and 109.5 degree. Okay, understood?
Yes.
Yes, sir.
Have you drawn this one?
Yes.
Okay, now moving to the next one is, if we have sp3d type of hybridization, then what should be the shape of the molecule? sp3d means 1 and 3, 4 and 1 5. They are the 5 shapes. Okay, then how can we say that the type of bond? So here we will have one s orbital, 1s orbital is mixing with 3p orbital and plus 1d orbital. Okay, when they intergo together, when they intermix together, they will gives you, okay, they will gives you how many new orbitals, new hybrid orbital? Tell me how many new hybrid orbital will be there?
5.
5. Yes, 1, 3, 4 and 1 5, and they will be of sp3d. Okay, sp3d hybrid orbital will be there. Okay, and if we will have 5 sp3d orbitals, and their shape, you can have shape like this, as we are just writing this is sp3 new hybrid, sp3d hybrid orbital, and there should be 5. Okay, there should be 5 sp3d to sp3d sp3d sp3d. Okay, and sp3d, they are the 5 orbitals. And how will they mix together? The 3 of them will mix in a plane. Okay, they will be in the plane. Okay, and making an angle of 120 degree between them. Okay, this is 120 degree in between them. Okay, understood? So each of them is going to have 120 degree. 120 degree. The 3 are like this, and one is, if you are having this like this in a plane, and if you have a sheet and you draw a trigonal planar structure like this on a plane, then one bond will be between above this one and one will be below this one. Okay, so if you take the sheet like I'm showing you here, that if you take the sheet like this, and if you have if you have 3 structures on the plane, 1 2 3 here. Okay, and the fourth one will be on this one, perpendicular to this one, and the second one will be this one. So if you have one bond will be like this above the plane, okay, and one will be below the plane. So if we make this structure without showing this structure, we made the structure like this, so it would be like one central atom here, okay, and this and this, and here we will have one, and here we will have one. Okay, so if you are having the bond angle, because this is going above the plane, let me show you like this. Understood? So this is the trigonal bipyramidal shape. Understood? So this is in the plane. We will say that these three are in the plane. These three are in the plane. Or we can have these three in the plane, in the same plane. And this will be above the plane. This will be above the plane, and this will be below the plane. Okay. So this is making bond with 90° with this one. This is also making bond with 90° with this one, because any bond, if we are having three bonds on this plane, let me show you here. Let me show you here. So if you are having this plane, okay, and if I draw three of them like this, three bond angle, like 1, 2, 3 on a plane, okay, like this. So everyone is going to make 90° with this one. Okay, so if I put it here on the marker, here this one, so this bond, and every bond is making 90°. So there will be 3 90° with this one, 3, because this is making 90 90 90 with each, and 3 90° with there. So how many 90° bond angle will be there? 6. How many 90° bond angle will be there? Tell me.
6.
6 will be there. Okay, so if I show you here, so there will be 90, and then again this will be also 90°, and this will be also 90°. So there will be 6 90° bond angle will be there. So if I talk about the number of the bond angle, okay, so bond angle, the 90° will be 6. Okay, and there will be 3 bond angles which is going to have 120°. So if I talk about 120°, there will be 3. Okay, there will be 120° will be 3. And if I talk about that, how many of them will be of 180°? So 180° means that this one, okay, here in the plane, of if we consider this as a plane, this is going to have 3 bonds here. So this one and the previous one here, they both are going to have 180°. So if my hand is in between these two, okay, so this and this means the upper one and the lower one is going to make 180°. So here this one and this one, the upper one that is going above the plane, and the one this is going to below the plane, this is going to have 180°. So if I talk about the bond angle, number of bond which is going to have 180° angle, so this is 1. Okay, understood? What type of geometry you see here? This type of geometry is called trigonal. Why trigonal? Because this is trigonal structure, and pyramidal shape is here. You can see that this is the pyramidal shape that is coming here. So this is the pyramidal like shape, pyramidal like structure. Okay, so this is the pyramidal like structure. And why bipyramidal? Because this is at the top and the bottom also. So why we called it? So this the structure is going to have trigonal bipyramidal shape. So when a structure is going to have hybridization sp3d, then it has the shape of trigonal bipyramidal shape. The geometry will be trigonal bipyramidal. Okay, understood? Trigonal bipyramidal. Understood? Understood?
Yes.
Have you drawn this one? Noted this one?
Yes.
Okay, should I move forward? No, huh? Have you done that one?
Yes, sir.
So if I talk about the next one is if we have the next type of hybridization is sp3d2. So how many 6 type of new hybrid orbital will be seen? 3, 1, 4, and 2, 6. So now the new arrangement of 6 sp3 hybrid orbital, because they are of same energy, so they will going to have bond. Okay, so how will be the new structure? So there will be new structure with a central atom at the center. If I'm just considering C as a central atom, okay, or we can consider A as a central atom. So they will be going to have this B, a new orbital will be like this B, and this will be also B, and this will be also B. So they will be going to have 4 hybrid orbital like this, and 1 hybrid orbital will be like above the plane, and 1 hybrid orbital will be below the plane. So in the previous one, we were having 3 in the same plane. If we consider 3 in the same plane, and 1 above the plane and 1 below the plane, 1 into the screen and 1 coming out of the screen. Okay, so if this is similarly, if we have 6, because this one having 3 and plus 2, that is one having 5 orbitals, but here we have 6 orbitals. Okay, so 4 in the plane, and 1 above the plane and 1 below the plane. Means if we have a sheet of paper, 4 in the plane, 1, 2, 3, 4, and 1 above the plane and 1 below the plane. Understood? Understood?
Yes.
So if I talk about that, how many this type of structure will be octahedral structure. What we call it, octahedral or square bipyramidal structure. Okay, so let me draw this one with some different colors so that you can understand. Okay, so this is square by pyramidal, square bipyramidal. So what does the word square bipyramidal means? What is the word square bipyramidal? Square means the plane will be in the square and one above pyramid will be formed above pyramid. This you can imagine that this can be like this, one above the pyramid. This is a pyramidal shape. Okay, this is the pyramidal shape. So one such pyramid is above and one such pyramid is below the plane, like this. Okay, so one pyramid is above, so one pyramid is below. So this is also called square bipyramidal, or we called it octahedral. So if any central atom is going to have sp3d2 hybridization, then the shape of that molecule will be tell me, square bipyramidal or octahedral shape. Okay, then how many bond angle will be there? So number of hybrid orbitals will be 6. Okay, understood. And the bond angle, so you know that this is going to 90, this is going to 90, this is going to 90, because they are in the diagonal of a square, and squares of diagonals bisect each other at 90 degree. So this is 90, this is 90, this is 90, this is 90. Okay, and if anything which is in the plane, which if there are 4 things, so they will make 4 bonds which is of 90 degree. One with this one here, one with this previous one, and one up. Means all the 4 one. If you are having a phone, let me show you. So if this is a phone, and if we have this over this one, okay, then this is going to make bond angle with all these 4 plane, 1, 2, 3, and 4. So here the bond which is above this one, so it is also making bond with this 90 degree, with this one 90 degree, with this one 90 degree, and with this one also 90 degree. Why? Because it is above the plane and it will be making 90 degree with the whole plane. Anything, if there are 6 bond on the plane, then they will be making 6 90 degree. If you're looking at 1000 bond in this plane, then it will be making 1000 90 degree angle with this all. Okay, so if we have a circle and if we have a numerous numbers of like this, so if we have a something circle on this plane, and if we place a perpendicular like this, so it will be making bond with 90 degree with each of them. Okay, you understood? Understood. So how many bond angle of 90 degree will be there? 1, 2, 3, 4 with this plane, 1, 2, 3, 4 with this plane, and 4 with this one. This one is making 4. Okay, and 4 below one will make. Below one will also make 4 90 degree angle. 1 with this one with this 2. Okay, like this. So this will be making like. So there will be 12 such bond which is going to have 90 degree. Okay, the bond angle is equals to 90 will be 12. 12 such bond. Okay. So let me write it properly. Bond angle 90 degree. Number of bonds will be 12. Okay, understood? And how many will be of 180 degree? Tell me. How many will be of 180 degree?
1.
There will be 3. Okay, how? The 2 will be here. 2 will be in the structure. Okay, like this one is going to 180 degree and this one is going to have 180 degree. And 1 and 1, this one. This one is the above one and the below one will also going to have 180 degree. So bond angle 180 degree and number of bonds will be 3. You understood?
Yes, sir.
The next one is sp3d3 hybridization. sp3d3 octahedral shape. So just I'm going to, because sp3d3 is very rarely asked, so I'm not going to draw the structure here. I'm just going to write here only. Okay, so sp3d3, here the number of atomic orbital will be, number of hybrid orbital will be, tell me. Number of hybrid orbital will be 1, 3, 3, 6, 7. Okay. When 7 atomic orbital will be there, then tell me, it will going to have a shape of pentagonal bipyramidal, means 5 on the pentagon like this, 1 above the plane, 1 below the plane. So pentagonal bipyramidal. Okay. The shape will be pentagonal bipyramidal. Pentagonal bipyramidal. Okay. Understood? Understood?
Yes.
Okay. And we will have bond angle here. You know that 5 here the bond between pentagons is actually 72 degree. So how many such bond will be there? With, so there will be 72 degree bond angle with 72 degree. Number of bonds will be 5. Number of bonds will be 5. Okay. And the bond angle with 90 degree will be 5 and 5, 5 above and 5 below will be 10, because each of this bond will be making a 90 degree angle with this one. Okay. And 5 below. So if we have there will be 10 total. Okay. And 180 degree will be 1 only. Will be 1. That is above and below 1. Okay. Understood? Understood?
Yes, sir.
Yes.
Now there is some special cases that you will going to study, that we have studied that sp3d, and this is going to have 3 and 1 and 3, 4 and 1, 5. 5 means 3 in the plane, 1 above, 1 below. But there is a type of hybridization which is sp, this is a dsp2. Okay, dsp2. Like we have sp3 hybridization. So this is going to have 4 hybrid orbital. They will be in the tetrahedral structure. So when we have sp3 hybridization, and for this we have how much? Tell me. For this we have tetrahedral shape. Okay, tetrahedral shape. sp3 means 4 means tetrahedral shape. So, but there is a type of hybridization that is dsp2, where the d orbital and 1s and p orbital, that we're going to study when you are going to study the coordination compounds. So we're going to discuss this one later. Okay. So dsp2, if there is a dsp2 hybridization, then the type of shape will be square planar only. Shape will be square planar. Okay. So if four molecules are being attached with the central atom, so the one possibility is like this: 4 with his central atom, that I'm taking this one as A, and this is B, this is B, this is B, and this is like tripod structure. Okay, tripod structure. Okay, let me show you this one in a proper manner. This is like this. And this type of structure is called tetrahedral structure. This is B, this is B, this is B, this is B. So this type of structure is called tetrahedral structure. This is the tetrahedral structure. Tetrahedral. This is also going to have 4 hybrid orbital, 4 sp, but here will be sp3, 4 sp3 hybrid orbital. Hybrid orbital will be like there. But if we have dsp2, here is a d is 1, s is 1, and p is 2, so we will have plus 2. So you will get also here 4 hybrid orbital. But when we have four atoms or 4 dsp2 hybrid orbital, when they are mixing together, then they will have square planar structure. Okay, this is B, this is B, this is B, this is B. So when we have hybridization sp3, then the structure will be tetrahedral, and when we have hybridization dsp2, then the structure will be square planar. So this will be a plane on a paper, and all the orbitals, this is all the 4 hybrid orbitals will be in this structure like this. Okay, so this will be the shape will be square planar, a square planar shape. Okay, and we will have the hybridization as dsp2. Okay, so when we have dsp2, the hybrid orbital is still 4, but the shape will be square planar. But when we have hybrid orbital sp3, then they will arrange themselves in the tetrahedral structure. You understood? Understood?
Yes.
Understood? And here the bond angle in this structure, here the all bond angle is of 109 degree. In this all bond angle is 109.5 degree. I'm just writing in short, not writing 28 minutes. Okay, in the tetrahedral structure. But here bond angle are different. Here we have two bonds angle with 180 degree, with one this one, with one this one, and 4 we are going to have 90 degree, this one, this one, this one. So 90 degree will be 4, and 180 degree will be 2. Okay, so their objective questions comes in examination that we're going to discuss here, at what type of questions will be going to come in your examination. So please note it down fast, then we're going to practice the questions. Done? When you're done, please let me know first.
Done.
Done. So if the questions comes that in which of the following okay, in which of the following the hybridization of central atoms in all the species is similar? In which of the following the hybridization of central atom in all the species all the species is similar? So if we have first option as XEF2, second is BEF2, third one is OF2, fourth one is SF2. The second option is an nitrate ion, NH2 minus 1, CO3 minus 2, and SO3 minus 2. And next one we have XEF4, then SF6, then we have PCl6 minus SOF4. Okay, then we have NH2, and we have SO3 minus 2, and we have CCl4 minus CCl4 only, and there is ClO3 minus 1. Okay. So which of the following is going to have the same hybridization? Central atom is going to have same hybridization. So you can check in this one that this and this is going to have same because they are going to have the same atomic number, same valence electron. But here this is not going to have the same. Why? Because the central atom beryllium has only 2 electrons, but here we have 6. So their hybridization will change. Okay. Are you getting my point? What I'm saying? Here the hybridization of this one will be 6 for the oxygen, the outermost shell, electron 6, 2,6 electronic configuration of oxygen, and that of sulfur is also 6. So we have 6 plus 2 monovalent atom divided by 2 will have 4. We will have 4. So 4 means sp3. So this is sp3, this is sp3, but here we will have BF2. You have also discussed this one, that this is going to have sp hybridization. Okay, sp straight line. So in the structure, so this is not in the central atom, this is not going to have the same hybridization. Okay, understood? Are you getting my point? And how can this and this will have the same, because this is monovalent atom, sorry, divalent atom, this is monovalent atom, so their hybridization will also change. Okay, so this is not going to be the correct option. Why? Are you getting my point? This is going to have 5 valence electron, and this is 0 monovalent atom and plus 1 negative charge. So divided by 2, you will get 6, divided by 2, you will get 3 here as a hybridization number. But here you will get 5, 2 monovalent atom and 1 negative charge divided by 2. Here the total is 5 plus 2, 7 plus 1, 8, 4. You will get 4. So here is sp3 hybridization and here is sp2 hybridization. So the hybridization is changing. Okay. So check in C whether it is same or not. Check it fast. Done? Tell me fast. Check whether xenon tetrafluoride and SOF4 is going to have the same. You can simply justify here that this is SF6 and this is SO4. O does not matter here. Why? Because O is actually not a monovalent atom. So we will consider this one SF6 and SF4 only. Okay, don't consider this atom. Why? Because we are not going to add any or subtract this one because it is going to have, it is divalent. O is divalent. Okay. So they are not going to have the same. Why? Because here we will have 6 plus 6 divided by 2. Here we will have 6 plus 4 divided by 2. So here we have 5. Here we have 6. Okay. Are you getting my point?
Yes, sir.
Yes.
In D, calculate in D. Here you will have divided by 2 is common. Okay, just add the numbers. Because when you divide it by 2, you will get the same. So just check the numerator. The numerator value is same, then the hybridization will be same. Because if you divide 5 divided by 2, or if you are getting the same numbers in everyone, then divided by 2 will be also same. So just calculate their number, hybridization numbers, just a numerator of that hybridization number. Here we will have 5 plus 2. Here we will have 6 plus 2. Why 6? For this one, and y plus 2 because of this charge, because this is, we are not adding 3 this one because this is divalent. Then carbon is 4 and 4 plus 7, 4 plus 4, sorry, CCl4. Okay, then chlorine has 7 electron in its outermost shell, and we will not going to deal with O because it is not a monovalent atom, and then we will add -1 because it is negatively charged. Okay, so this is going to have 7 in H2. Okay, and this is going to have 8 NH. NH -1 should be there. NH -1. Yes, it should be -1. Okay, NH -1. Then we have this one as 8. -1 will also be added to this one because minus charge is added. So this will be 8. This will be 8. This will be 8. This will be 8. So this is the D is the correct option that is going to have all the central atom is going to have the same hybridization. Okay. Understood my point?
Yes, sir.
Okay. So if we have okay. So if we have a question from the NEET exams, so bond angle between two hybrid orbital is 90 degree, then the percentage of S character in the hybrid orbital will be, so bond angle between two hybrid orbital between two hybrid orbital is 90 degree. Okay, then percentage of S character in hybrid orbital will be okay, tell me. So if we have one is 25%, second option we have 20%, third option we have almost 17%, and we have almost 14%. So how many structures we have that is going to have bond angle as 90 degree? So SP is not going to have any 90 degree because it is a straight line. Okay, SP2 is also not going to have any 90 degree because it is going to have the structure like this. Okay, trigonal planar. SP3 don't have any 90 degree because it is going to have tetrahedral structure. SP3D is actually has 6 90 degree angles because it has 190, 290, 390. Okay, means every bond, this bond is making 3 above and 3 below. So we have 693. Okay, 690 degree angles. Okay, and the next one. So tell me what is the percentage of S character in this one? So you will see that there is only, if we draw these fractions of this one, we have 1s, and out of total number of hybrid orbital 1 and 3, 4 and 1, 5. Okay, so out of 5, S is going to have, if we need to divide this circle into 5 parts, then S character will be of 20% only. Okay, so here if we have 5 parts, then S character will be, okay, here it is 50% S, 50% P. Okay, here it is 50%, 3 are there, the 33% S and 66% P. Here we have 4 orbital to 25% S and 20. Okay, understood, and 75% P. Are you getting my point? 3P,
Yes.
if we have 4 parts, then 4 parts, if we divide 25, so 75% will be given to the P, and only 25% will be given to that. Okay, so in this one, we have 5 parts. So if we divide 100 into 5, the 20 fraction will be there. So S will get only 20%. Okay, and these above are not, I'm just going to explain you this one because, okay, So I'm just expecting time. Okay. So similarly, so if we are going to have, we need to calculate. So in SP3D, we have 20%. Similarly, you calculate in SP3D, D3 and DSP2. So we will have 17% in this one and 14% in this one, and DSP2. Okay. Sorry, 25% in DSP2. 25% in this one, and SP3 D3 we have 14% only. Okay. So almost all the options we will say that here, that 25% is also there, 20% is also there. Okay. And okay, so this is correct. Almost 14% may be there, 17% may be there. Okay, 20% may be there. Okay, and 25% may be there. So they can have any values. We're going to discuss this one in the next class. So that's all for today, and we're going to discuss the next molecular orbital theory in the next class. So please be there on time. That's all for today. We'll meet you in the next class. Okay.